How many of you wait impatiently by your computer, waiting for that new DNA match to come through that will just break down your brick wall? Well, I want to share a strategy with you today to find new and additional matches, ones that you already have that can maybe do the same thing. In today's video learning module, we're going to learn how to use small DNA matches to help us research more efficiently. We're going to talk about, first of all, what is autosomal DNA and how do we inherit it, because that's going to help us understand how to use these small matches and when these small matches are potentially valid. We'll do this within a case study where I show you where I've used small matches to help me better understand a genetic network of matches that are related to my Boyd ancestry. We'll also use a DNA tool called DNA Gedcom Client to help us understand and identify these small matches. And so I'll show you how to use that in our research. As we start off, we want to talk about what is autosomal DNA. Now, we know that autosomal DNA is inherited from both parents, and we inherit it equally from both parents, and it appears within our 22 pairs of autosomal chromosomes. The image to the right shows two first cousins, my father and his cousin, and the blue portion demonstrates the areas of autosomal DNA that they inherited from the same grandparents. And when we look at this, this is what we're going to be studying. And one way that we will talk about small DNA matches is through its measurement, what is called a centimorgan, or is abbreviated as cm. This is a measure of genetic distance, and a distance of 1 centimorgan equates to about 1 million base pairs of our DNA. And in our autosomal DNA matches on Ancestry or My Family Tree DNA or any other testing website, we have about 7,400 centimorgans of data that we look to see if we share with our cousins. And the data which they look to match and say we are and we do share DNA is associated with the base compounds in our autosomal DNA, which is adenine, cytosine, guanine, and thymine, or A, C, G, and T. And so this is a foundational element that's going to help us to interpret the data that I'm going to present today. So let's define what a small segment is. Again, we're going to define this within centimorgans. And when we talk about this, I have a ruler here to kind of demonstrate what I mean by the size of our match or the segment that's associated with that match. The amount of centimorgans, if we share something less than 6 or 8 centimorgans, I'm not talking about those as small matches. Testing companies don't even provide us that level of data. Typically, that's because most of those matches that we have are going to be false matches, or we can't guarantee that they are accurate and true cousins. Now, it varies between 6 and 8 centimorgans just because depending on the testing company. For example, Ancestry only shows matches that are 8 centimorgans and greater, whereas Family Tree DNA shows 6 centimorgans or greater. Typically, when we look at segment size, we want to focus in on those that are 15 centimorgans and greater. Genetic genealogist Blaine Bettinger defines this as the safe zone. Where he calculates, and Family Tree DNA confirms this, is that more than 99% of our matches at 15 centimorgans or greater are actually likely to be true genetic cousins. And so when we're looking at matches, we want to concentrate on those matches that share at least 15 centimorgans or greater. However, there's this place in between that cutoff where testing companies don't show and this safe zone, which is between anywhere from 6 to 8 centimorgans and 15, that as many as 20% can be false matches. And there's obviously a good portion that are true matches, but it's difficult for us to discern which ones are true matches. I'm going to walk us through a point later on that will help us figure out which ones might actually be true matches and can help us in our genealogical research. So let's talk about how autosomal DNA is inherited. And I think most of us know this, but I want to kind of talk about this so that we understand why small DNA segments are potentially risky to use in genealogical research. So just to reiterate, this is typical inheritance, and I'm showing you the great-grandparent level. And we're going to assume that each grandparent represents their unique DNA profile associated with a different color. With each generation, we inherit 50% of our autosomal DNA from each of those parents. So you can see here, it takes about 50% from each generation, and this gets more diluted from those original great-grandparents level until we arrive to where we are today, our individual, and we're going to assume that's the person being tested. Now, this image right here shows it pretty nicely divided in perfect halves or quarters, but the reality is inheritance of autosomal DNA is random, and so as it now shows, you can see that it is not so equally split, and the randomness continues throughout each generation. So when we look at this, I'm going to introduce now something new. On the right-hand side of this image is a new descendant. Not one of our direct descendants, but a sibling to one of our grandparents. And what I'm going to demonstrate is what we are looking at, which this slide is titled Identical by Descent, or IBD, is when we know it's a good match. Because the DNA we share, when we have that match, it's identical because we inherited it from the same grandparent. So that's why we say identical by descent. So if we look at this, that sibling of our grandparent, you can see that we share a number of DNA, the same colors, maybe different chromosomes they're represented on, but we pretty much share the same DNA. But as different generations come, we lose some of that original DNA because in this example here, our cousin had inherited DNA from a different parent or grandparent that is represented by gray here. So some of that original DNA is lost with each different generation. And as we get closer to what would be a peer of ours or a cousin, you can see here that the amount of gray represents area that we don't share in common. But you can see here this green and orange, we actually do share in common. And that represents, if we were to match with our cousin, and we certainly would at this level, that green and orange represents that shared match or the amount of DNA we share in common. And we share it in common because we share a great-grandparent, and the DNA that we inherited is identical, what we call by descent. Now, the problem with when we look at small DNA segments is because of a similar process which is called identical by state, which means we may have some values in our DNA, those A, C, T, and G values, that's the bases of our chromosome DNA. We may actually have some of the same values, but it's not because we inherited it, it's because the segment is so small that it looks the same because it might have the same A or C or T or G. So let me kind of explain this. So again, we see somebody here in gray on the far right-hand side. The gray says that we don't share any DNA with these people. There's no colors in common. And I'm going to highlight a portion of their genes just to say, like, there's this big segment here that clearly we don't share. It's all in gray. But again, with each generation, the amount of original DNA, even with that person we don't share anything with, gets smaller and smaller. And such that at in many generations, if we're looking at that segment, it's really small, and it may look similar to our orange segment just because it is so small that the values, the A, C, T, and G values that are in their DNA may look similar, even though they didn't inherit the same ones that we did. But because it's so small, that values may look like they do match. That would be a false match. And when we call those kind of false matches, we would say they have identical values, but it's only by state because it looks the same, but we didn't inherit it. Let me explain this a different way. Again, looking at autosomal DNA, looking at the A, C, G, and T values, let's assume that this was like a word tile example. So we have these square tiles, and the only thing in this bag is an A, a C, a G, and a T. And let's say we have great-grandma's DNA segment that is maybe 20 centimorgans or 15 centimorgans in length. It's quite a large one. And going across there, the values are the various combinations of A, C, G, and T. What is the likelihood that we would take one tile at a time and randomly pick it out of that bag, and we would come up with something that matches grandma's DNA? So we'd pull up an A, and then the next tile we pull up is a T, another A, then a G, C, T, G, G, and C. Like, what is the chances that we would randomly pick that? Well, mathematically, that is greatly lower than 1%. So it's not very likely. So the only way we would have that, be able to draw that exact combination out that matches grandma's, is if we inherited it from grandma. Now, let's take a small segment of that. So let's say we randomly pick out an A, and then we randomly pick out a T. What is the likelihood that we can actually do that? It's a smaller segment. Mathematically, the chances of us doing that is 6%. So there's still a possibility that we could, but again, it's very small. And so that's the danger we have in looking at small segments, because there is a chance that we could pull it out of a bag randomly and have that match. But the longer that segment, the less likelihood that we would have, we'd be able to do that out of random. And so therefore, the longer one represents identical by descent, whereas the smaller one could be identical by descent if we did actually inherit it that way, but it also could be identical by state. And that is the problem we have with relying on small segment matches. So let's kind of return back to the segment sizes here and the guide that we use in genealogy. So we know that we want to focus in on DNA segments that are 15 centimorgans in length or greater. If we were to look at in Ancestry, if we look at this, those ones that are in green are ones that we can use for genealogical evidence. But these ones in the yellow, testing companies provide it to us. But there is, as mentioned before, a greater likelihood of some of those being false matches. But I am going to advocate that there's some of these small matches that may be useful. It could help us identify some of these larger matches, or at least tell us within these larger matches which one of their grandparent lines is the one that we should be investigating or spending more time trying to discover how we're related to them. I believe that some of these smaller matches can help us, like a compass, pinpoint which one of those great-grandparent lines to spend time researching. And the way that we know that the smaller matches are going to be helpful is if these small matches are valid, meaning they must possess a collaterally and conditionally linked genetic membership with these larger matches. What do I mean by this? That means that smaller match below 15 centimorgans should be part of the same genetic network as that 15 centimorgan match. In other words, when we look at that match and we look at the shared matches between me, the test taker, and that other large match that's 15 centimorgans or greater, that smaller match should be also part of that genetic network. They should also be matching those myself and some of those other matches. It should also be conditionally linked, or what I mean here is that it should have a common ancestor with one of those matches that are 15 centimorgans or larger. If it doesn't have a ancestor in common with one of those 15 centimorgans or larger matches, it is not linked. It is not going to be helpful to us. And then lastly, that small match should not be a direct linear descendant of one of those larger matches. If it is, it doesn't provide us any additional value because it's not going to help us identify one of those great-grandparents in which we should be looking to research more specifically. In other words, it should be collaterally matched, so not directly descendant, which means it shouldn't be a child or grandchild of one of those larger matches. So let me walk us through an example here, because I think that will solidify what I mean by looking for a conditionally and collaterally linked one with genetic membership, and how we can actually utilize this in our research. So I have, in my research, I am researching my Boyd ancestry, and I'm using DNA to do this. Outside of DNA, I discovered that my ancestor, James Boyd, was a witness to a 1751 will of a Henry Benson in Bucks County, Pennsylvania. And I'm wondering, why would James Boyd witness this will? Is he a neighbor, or is there something greater? Is he perhaps genetically related to Henry Benson? So this is kind of where I was. What I wanted to do is look for a DNA connection between the Boyds and the Bensons. What I did find is what we call an unlinked family cluster, which is a group of DNA matches that descend from these Bensons that also appear to be related to my Boyd ancestry. So I found 23 matches that were part of this shared matches or shared network, this genetic network. And so what I found was, and you can kind of see it in this picture here, that of these 23 matches, 5 matches were related to these Bensons. And the Benson match that I found that was the greatest match, that had 30 centimorgans, when I looked at the matches that my cousin, who is related to me, and a direct descendant of William Boyd, they shared 30 centimorgans with this Benson match. When I looked at the shared matches between this Benson match and my cousin, all of the other matches showed up, 5 of which descended through 2 different child lines of these Bensons, and 9 descended through 3 different children of William Boyd. And so that provides me some level of confidence that this cluster is related to the Benson side and the Boyd side, but I can't yet figure out how. What I need is, can I identify some other matches that either help me bridge that gap between the Bensons and the Boyds and figure out how they're related, or provides me some other level of information that will help me research this maybe offline outside of DNA through traditional records. There were 9 kits that I couldn't associate with either Benson or Boyd. And looking at these unknown matches, I noticed that 4 of them had private trees and 2 of them had no trees. I contacted them, didn't hear anything back, so these are providing no additional value. However, there were 3 of these matches that had trees. 2 of them were for a mother and a daughter, and they couldn't connect them to either Boyd or Benson. I couldn't find any helpful item there related to those. The one other match did have some Bucks County ancestry, but again, I couldn't connect them to my either the Boyds or the Bensons. But I was very curious about this other match there, the one that has the Bucks County connection. But when I look at their ancestry, they have 32 great-grandparents lines that I could investigate, but I don't know which one would be the most appropriate to investigate. When I look at this, I of course see the Bucks County one, and I want to investigate it. It looks promising, but as we all know, sometimes just by chance we have a match that lived in the same county, but it doesn't mean we're related. So I didn't want to go after this shiny object. I wanted to have more data. When I look at my cousin, whose matches I'm looking at, I look at where her ancestry is from. Immediately when I look at this other match here, they have ancestry from Greece and some French-Canadian ancestry. My cousin doesn't have any Greece or French ancestry, so I can rule out those lines, but still I have a great number to investigate because my cousin does have German and Irish ancestry. And of course there's Virginia and Pennsylvania, and I'm not sure where those ultimately end up. So I want to look for, can I find additional matches that help me to figure this out? So let's return back to this, the centimorgans and which ones might be helpful. Of course, we want to focus in on the 15 centimorgans or greater, but ironically, ancestry, when you look at a shared matches, when you look at that 30 centimorgan Benson match and my cousin, and I click on the shared matches feature, ancestry only shows those matches that are 20 centimorgans and greater. What about those other centimorgan matches that are between 15 and 20? I'd like to see those, but Ancestry doesn't show them to me. Also, there's those matches that go all the way down to 8 centimorgans that Ancestry also captures, but isn't showing. Now, granted, some of those below the 15, there's greater chances of some of those being false, but there's going to be a number there that might be valid. So how can I capture those or look at those? And can those provide me a way to see if some of those larger matches, where I should be looking to investigate? So kind of returning to that 20 centimorgan unknown match that has this Bucks County ancestry that I'm so curious about, but unsure whether that's truly how they're related. What I want to do is find another match that can act like a compass. And I actually did. I found another match that is 9 centimorgans, which is below that 15 centimorgan threshold, that I don't want to use as genealogical evidence, but maybe it can show me which one of these other remaining grandparent lines I should be looking at and spending my precious time investigating. And in fact, this 9 centimorgan match did actually do that. It had a common ancestor that only had a common ancestor with this 20 centimorgan match that shared that same Bucks County, Pennsylvania ancestor. So what did I find? This match, this 9 centimorgan match, shared a common ancestor with what is Joel Stewart and his wife, Sarah Price. Now, I call this a micro unlinked family cluster because a normal unlinked family cluster is much larger than this. Like, the example that I had for the Benson one, had at least 5, but this one only has 1. So I call it a micro unlinked family cluster. And whereas my tester and the 21 centimorgan match was part of the same shared network with the Benson one, this 9 centimorgan match was a member of the tester or my cousin, whose matches I'm looking at, and this other 21 centimorgan match. So it's part of the same genetic network, at least as the 20 centimorgan one, but unfortunately not the same one as Benson. But it still can be helpful to help us to research which genetic or which great-grandparent we should be concentrating on. So can we ensure that this new 9 centimorgan match is actually valid? Well, let's take a look at it and see how it compares to the qualifications that collaterally and conditionally linked genetic membership that I spoke about earlier. Well, the first condition, is it part of the same genetic network? Well, it's not part of the Benson network, but it is part of the same genetic network as that 21 centimorgan match. So it does at least meet that. It does share a common ancestor with a match that is genetically useful. So it is one with a larger 15 centimorgan or greater match. It's obviously part of that 21 centimorgan match, and it shares a common ancestor with Joel and Sarah Ann Price. And for the last aspect to ensure that it is valid, it does not share a direct linear descent, meaning it's not a grandchild or a child of that 21 centimorgan match. In fact, it shares a collateral line, so going much back further to that Joel and Sarah Ann Price. So that is meets those 3 conditions. So let me show you how I found this smaller match. I use a software called DNA Gedcom Client, which is a pay-per-use type of software. You can either pay monthly or annually. It's a nominal fee, but still a fee nonetheless. And what it does is allow you to download some software to your computer, and it allows you to access a lot of data from whether it's Ancestry, whether it's family tree, DNA. It will pull information and download it into a spreadsheet like list of all your matches and who that match also similarly matches and what the size of that match is and even some of their family tree information. So let's go look into the DNA Gedcom Client. I'll show you how I gather those matches, how I analyze those matches, and what I discovered and how I found that 9 centimorgan match. Okay, so we are logged into the DNA Gedcom Client, and what you want to do is go to the Gather tab and then select Ancestry, and then you will enter your user ID and password, and then do web login. It will pull up the information here. And once you are logged in, you want to select your name of the one that you are wanting to gather the DNA matches for. And you have a number of different options here. You can pull the segment information, which is like the size of the match and some different match details. I don't really feel that's necessary for what we're doing here. You definitely want the in common with, which is the shared matches, which creates your genetic networks. Trees, For what we're doing here, that's not that important. That would gather the surnames available in different trees. It takes up a lot of space and a lot of time to do that. So I don't do that. What we really want to focus in on is just, I want to get a list of all of the matches and who they match. And what you do here is click Gather DNA, and it will start gathering the information. And you can see here, I have 15,000 matches, and it is going to take some time. It can take, depending on how busy their servers are, it could take a couple of hours to maybe even a day or two. I've had some cousins that I've pulled their matches for them, and they have over 50,000 matches. That takes some time. And what you do is just keep your computer up and running, or the next time you're back at your computer, it will finish downloading everything. So what we have here is that is being done. Now I'm going to assume that's done. And what I have and what it comes back is here are the list of the in common with matches. Now I've done a lot of privacy editing to this document. So the full match ID, which is really an ancestry type of information, it's not totally visible, so it doesn't really provide anything. The match name, I've put them into abbreviations, and what you have going across here is the match name. So this one is here for a match called MC, and there you can see here there's a column here for match name and match administration. So this would be, if you see this, like for my kit, if it was here, my match name is my match name, whether it's Rick Wilson, and the administration would be whatever my Ancestry user ID is. If it's the same as the match name, it will show the same. But if I manage multiple kits, and I do, the match name would be the name of the kit, and the match admin would be me, and for whomever cousins else I manage. That's the differences there. The in common with ID is the same as the match ID, but for the match who you have in common with. And so that correlates here to the in common with name and the in common with admin. Same type of fields here. And so you can see here that the match MC that I have matches somebody that is abbreviated AH, and it is administered by somebody who has the administrator is just an L. So I've abbreviated, of course, so to privatize it. And so you can kind of see down here. Now the source, in case you have multiple files, this was pulled from Ancestry, so that is right there. The notes field is an additional field that I added. And this is where I've noted that this match name right here, AH, it is a private, but I've noticed that the name of the file or some other file with it, even though the kit is private, I noticed there was a surname associated with one of the names of the common with name or the admin. So I thought that was interesting, so I put that there. Here are some of the Benson matches and the Boyd matches. But what I really did, and this is what it comes down to, is this B match is the match that is 30 centimorgans that we saw. That was the principal match. And here are all the matches, and you can see that I have some of the notes here written down, not all of them, but a number of them. What you see here is the way it typically lists them is in the order of the highest matches in terms of the highest number of centimorgans are going to be listed up on top, and then it scrolls down to the point where it is picking up. And one of the last matches that I had in Ancestry at the 20 centimorgan match level was this one here. I believe it was the L match here. And then all of these other matches below that are ones that Ancestry didn't display for me. So that is all of these matches here. Those are new matches for me. They didn't show them. Now, they may be outside. Some of them may be certainly below 20 centimorgans, and some may be below that 15 centimorgans. But that's ones that I can investigate. One of the matches that I had there was the 21 centimorgan match. That is this one represented by MC. And when I look at the MC matches, here are some of those matches here. Some of those didn't show up with the in common with matches with this B1, which is a 30 centimorgan. So some of them are new. And in fact, that 9 centimorgan one that I found is represented right here and by RC. And so this is what this file does. Now, I've removed a lot of the file here just to make it more manageable and presentable in a privacy format. Now, what I do with this is I would copy and paste the in common with admin or the in common with name, and I would highlight it, do a Control-C, and I would go into my Ancestry account and copy this in one of the search fields to look and find that match, and then look to see if they have a family tree and if it's public and if I'm able to search it. So what I typically do, and again, these are made up, but when I see that the in common with name and the in common with admin are the same, it doesn't matter which one I pick to highlight and copy. So I'll do like a Control-C. And then what I do is go into my matches. And what I would do is click the search field. And here, see that where it says match name? I do a Control-V and I copy it, and then I'd click search. And again, this match is made up, so it doesn't exist in here, so I'm not going to click search. But when I do click search, what I might see is one of these. And if it has a tree, that's great. I can look at the tree, study it, see if I can find any common ancestors with some of the other matches or other data. And that's what I'm looking for. But if you see some of them have a different in common with name and the admin name is different, that means you can't just click on either one of these to search for it. The MWs you will never find. When you see initials like this, they don't show up. When you would do a Control-C and go back in here and put this and then click search, it doesn't show up. That Ancestry doesn't like that for a search field. What you have to do is search for the admin. So I would click on this one, put that in here, and then click search. And then what you would see is you see here where it says managed by, that RXCS, that's what would show up here. And then the MW would, but what you would see in these brackets here. Now again, I've privatized this just to make it easy for me to put this online. So, but that's what you would see, and that's how you can find it, because sometimes the admin manages multiple kits that you match, but you are looking for the one here that would say, in the example I have here, MW. Now, I also have another example here. When you see something here, again, the MW, you can't search for it. When they have a one field here where the match admin is just one phrase, it's easy to search. But when you have a name like this, like Richard Smith, you have to copy it. But what I found is that when I put this here, I actually have to get rid of the first name and then click search and look for all of the matches that have Smith in it, but that will have MW, and Richard Smith would show up here under this managed by, but it's the way the search field works within the system. I can't explain it, but that's how you can make it work for you. And that's how, when I looked at this, when I ultimately looked at this particular match, I found its tree, I noticed it had that Stewart connection, and that's how I found that 9 centimorgan match that was in common with my 21 centimorgan match that helped me to find an additional, or to know which one of those grandparent lines to spend more time researching. So hopefully you kind of now get a better understanding for how I use the software to identify that 9 centimorgan match. And if you have greater interest in learning more about this, you can read the companion blog post that I've written and available on my website here. You can scan that QR code and that will take you to it, where you can read more about it and learn the strategy